So we'll start our class from now. So now see, yesterday we saw about all those other parts of clouds, winds, then rainfalls. Then now today what we'll see different types of precipitation, and after that we'll see about the types of rainfalls. Then after that we have the time, then we'll see about the air masses. So we'll see precipitations, then we'll see rainfall, types of rainfall, then we'll see about the air masses. So all these three we'll see this in today classes, and if we have time then we'll see about the fronts. So all those slides already I have shared in the class. So now today we'll start our class with the different types of precipitations. So see, in the precipitations means what? When the our moisture with the air, warm air, that is going upwards, and that is going upwards, and that is condensing. Then after that it is falling down as a droplets of water, or you can say it as like snow. So that is particular process is known as the precipitations. So see, different types of precipitations we'll see. First we'll see what is precipitation. So condensation of water vapor. See, yesterday what we saw that this is our Earth surface. From this part having sunlight is coming. Okay, so here water bodies and all those and dust particles from the continental part. Then what is happening? Due to the terrestrial radiation, evaporation is happening. When the evaporation is happening, so after evaporation that liquids are turning to the vapor and they are going upwards. Okay, gas are going upwards. So upwards what it will happen? In the upper part, now see, after tropopause, wind won't have that much capacity to go across the tropopause also. So there what will happen? There they will start deflecting and they will start settling. Okay, and in upper part you all know that all those particles, dust particles, smaller particles, they are settling, they have settled down. Okay, so they are known as the hygroscopic nuclei. So those hygroscopic nuclei, on that part what will happen? That water vapor, as we go up, temperature is decreasing. So temperature is decreasing means what will happen? This part water vapor will turn into the liquid. Okay, or if you go above, if the temperature goes below 0 degrees Celsius, then it will turn into the ice. Okay, so when it turns to the liquid, so it will go and settle down on this small particles. So there it forms the, there what happens, that particular water vapor condenses on those small dust particles, on those hygroscopic nuclei. So that is known as the condensation. Okay, and when due to the heavy weight and due to the gravity pull, when those droplets of, when those nuclei, hygroscopic nuclei, or you can say it as the condensed part, when they start falling down as a water or as a ice or as a snowfall or as in a dust part, so that particular is known as the precipitations. So we have different types of precipitations. In that we can know that we have the snowfall, we have rain, we have sleet, we have hailstorm, we have freezing like a snowfall. So that is the all part of precipitations. The process of continuous condensation in air helps the condensed particles to grow in size. So this, how this precipitations happens. That condensed part will start becoming bigger, and after that, due to gravity pull, when they are not able to suspend themselves in the upper part, they will start falling down as a rain or as a snow or as a sleet or as a hailstorm. So that is known as precipitations. So we have different types of precipitation. So see here, on this our Earth surface, you know water cycling. So water cycling is what? Condensation will have. First evaporation will happen. Okay, then condensation will be there. Then again from there precipitation will happen on our Earth surface. Then again that particular, that water vapor will change. So again it will fall down as a water. So that is part of water cycle. So in our atmosphere, in two ways water evaporation is happening. One is evaporation normal. Water is changing into water vapor from the Earth surface due to the incoming solar radiation. Okay, and another is the transpiration. This is also types of evaporation. Okay, transpiration, where it is happening? It is happening on the plant's leaves. Okay, you all know that plants leaves. You all know that plants used to do photosynthesis. Okay, so on their upper part, little bit of water it will be releasing. Okay, so that time what will happen when the rain is coming, when the insolation is coming there to the leaves? So there what is happening? They are losing. To maintain their coolness, their heat loss is happening on these leaves. So that heat loss, that here liquids present, water presence on this part, what is happening? That is going upwards. So that is another transpiration. Okay. So transpiration is also part of which helps in the water cycle. So this is about the transpiration. Now next we saw about the precipitations. See, you all know that in upper part we have the hygroscopic nuclei. How this hygroscopic nuclei formation is taking places? Because see, in down pass we have all smokes released from the industries, vehicles, then dust particles. So all those particles are going and settling down. They are suspending in the upper atmosphere. Upper atmosphere is not in the troposphere. So they are settling down. Then when evaporation is happening, then evaporation with the moisture means air, warm air with moisture. It is going up. So as it is going up, it is going there and settling down. As you know that temperature will decrease as you go upwards. So temperature will decrease. Then what will happen? They will turn again into the liquid form. So again on the dust particles they will get attracted. So these hygroscopic nuclei, they will attract those moisture parts. So they will get settled here. Then there will be bigger clouds formation. They will first like a small hygroscopic nuclei will become big. Then again this will become big. Then two hygroscopic nuclei join and they will become big. So lies while joining they will become bigger. Then after that, when it is not able to hold themselves in the suspending air, then they will start falling down as a rain. So that is the precipitation. So this is how doing in the precipitation forms only water reaches to the ground surface. So precipitations that can be in the three states. You all know that we have the three states of matter, that is liquid, solid and gas. Okay. So in the three states, in the gaseous forms, if precipitations happens, in that three some other different types are fog, we have mist, we have dew. Okay, these are in the gaseous form. Then in the solid form we have hailstorm. Then we have the snowfall, we have sleet. So these are all in the solid form. Then in the liquid state we have rainfall. So that rainfall can be of different types: orographic, frontal, convectional rainfall. Okay, and drizzle. You also hear about the drizzle. So this is also the rainfall. When that rainfall is happening like a slowly, not heavily. Okay, and somewhat its shape is big. So that is known as the drizzle. So their shape is like 0.5 mm to 6.33 mm. Okay, so this is about the precipitation and their different states. Okay, in gaseous, fog, mist, dew, solid, hailstorm, snowfall, sleet. Then liquid we have the rainfall and other parts. So see here, now these precipitations, yesterday we saw that if we have the relative humidity as 100%, then only there will be the saturation of that dust particles. Then when saturation happens of that vaporization part, then only that will start there, that will settle on the, that will attracted by the hygroscopic nuclei, and after it attacking it will become bigger, then it will fall down as a rainfall. So relative humidity means what? Actual amount of moisture in the air. How much action? See in the downward part, what happening? Like here we have the at the 40 degrees Celsius. At 40 degrees Celsius, this particular droplets you can say, or you can say like dust particles. So here what is happening? It has the moisture holding capacity of like 1000 milliliter. Okay, that much moisture it can hold. Okay, but when it is in the down parts, sorry, you can say it here like 40 degree. When it is down part, it has this much capacity. Okay, and see, and suppose if its temperature decreases to 20 degrees Celsius, then here again here what happens? It has a like 700 ml capacity. Okay, so what happens? So as it is going up, so there what will happen? So here you can see that is this one capacity is full 100%. Okay, and here its capacity is here in this only this much 70 ml is present. So here what will happen? That means only 70% relative humidity is present. So if we have the 100% relative humidity, then that particular droplet, then only that particular droplet will become saturated. Okay, then after saturation only they will start settling on the dust particles. So now as we go up, temperature will start decreasing. So when it reaches the 20 degrees Celsius, so here we can see that at the 20 degrees Celsius its capacity is 70 ml. So there it attains the saturation, attains the 100%. Then after they will start settling on the hygroscopic nuclei and they will start condensation. So this is about the relative humidity. Because this plays an important role in the rainfall and the precipitation. Okay, so you must know about the relative humidity. If we have 100% saturation or 100% relative humidity, then only we can have the precipitation. So now in precipitations they are divided into different parts. So suppose if this is the mountain, okay, so as we go up, what is happening? Temperature is decreasing. So here in upper parts, what it is happening in the upper parts, like as it goes below 0 degrees Celsius, then that particular droplets that saturated will become into the snow, or you can say that will turn into the ice. Okay, so this is our ice line. So from the upper parts first, now this is a 0 degree. Okay, so here what will happen? We have the snowfall. If from this part precipitation is happening, then we have the snowfall. Then as we come, here it comes to downward pass, then we have the rainfall. Okay, because here temperature is increasing. Okay, and here what is that ice will turn into the droplets of water. So from here we have the rainfall. Then from the somewhat lower part, then we have the fog, and fog also known as the mist. Okay, so then from the downwards pass at the earth surface, so we have the dew. So these are the different types of precipitations. So what is mean by dew point? We all studied about the dew point yesterday. That at a given temperature, that air parcel is becoming saturated. So that temperature is known as the dew point. We all saw yesterday. Then see, 0 degree freezing means you all know that water freezes below the 0 degree. So lower than freezing point, we have the snow, hail and sleet. Okay. Then higher than the freezing point, then in that type we have the fog, dew, rainfall. Then what is mean by dew? So dew means what? Now in the previous diagram we saw that dew means it will be near to the ground surface only. Okay. So at this part ground surface we have the dew. Okay. So what is dew? So dew, first we will see the conditions. So dew means what? Dew, for the occurrence of dew, we should have the clear sky, we should have the relative humidity high, and then that should be the cold and long night. Okay. Dew means what? What is happening? This is our ground surface. Okay. So here what is happening? That water vapor. Okay. Water vapor, and this dew particularly occur in during the winter only. Okay. So remember, in the winter only it will occur. No, not in the summer. So dew, what will happen? Now these objects, they will settle down. All those dust particles, they will settle down near to the ground surface only. Okay. So in the daytime, what will happen? Now that all those condensed part, it will pass, they will get settled here. Okay. Now night time, what will happen? We have the heat loss from this part. In the daytime, this has absorbed heat. Okay. So night time you have the heat loss. So that heat loss, what will happen? This part will become cooler. Okay. And this part will become warmer. So here what will happen? Now due to warm air here, so this particular, that near to the ground surface, all those settled, this will turn into the water droplets. And that particular water droplets, if we see the earth surface, like in the morning, if you come to the northern side, so northern India, so in the morning you see water droplets on the earth surface. Okay. So that particular water droplets are a part of dew. So for this, temperature should be low, clear, sky should be clear, relative humidity should be high, and we should have the cold and long night. So this is about the dew point. And dew point is what here freezing. See here why it is not freezing, because we have the temperature high. We don't have that much temperature low to form a snow, or you can say it is a ice. So here we have the settling parts are there, and due to warm air, that particular what is happening, they are melting and they are falling down. So that is the dew point. So that dust are falling down due to the. And remember, in the dew we should have the temperature inversion also. Okay. So here, because of that only, now we have cool air is coming, warm air here it is happening. So we have the temperature inversion. So that dew, that morning when you see the water droplets on our surface, or on vehicle also you can easily see some water droplets during the winter season. So that is the dew. And similarly, what happens now in the mid latitudinal area, or you can say it in the fully like temperate regions area, like in USA. Okay. So there what happens, that particular dew, okay, that particular dew only what happens, their temperature is very less, below the 0 degree. Okay. So here see, now here temperature is above the 0 degree. So this particular is the dew. Okay. Now in USA side temperature is below 0 degree. So there what will happen, that particular, that earth near, that all those dust particles settle near the earth surface, they'll start falling down. So that start from them form in the form of frost. Means what, that ice particles, like on the, you can see it on the, if you see the tree, then on their leaves some ice particles like white color you can see on those. Okay. So that is known as the white frost. So that you can see in the USA part. So this is about the dew. So now see about the fog. So see, fog also happens mostly in the temperature inversion part only. So see, in the fog what is happening, we saw that as we go up, so there what is happening, temperature is decreasing, and due to heat loss we have the warmer air there. So there what is happening, that particular what is happening, that is melting down. So see, in this part fog what is happening, we know that industries and all those, they are releasing smokes. Okay. So when they are releasing smokes, so what is happening, when like mountainous part when you see, so first we have the dew, okay, then we have the fog. So that is also near to the earth surface only. So in during the fog what is happening, dust particles are settled in this, see, little bit dust particles are settled in this part. So there what is happening, when those parts, when some little bit of, when those parts, they are not getting moisture, but what is happening during night, they are cooling down. So that particular what is happening, that we are seeing, we have the like blurred regions in the downward in the earth surface. So in that blurred regions that we see during the cold winter time. Okay. So see, for this we should not have rainfall. For this also we should not have rainfall. For this also condition we should have clear sky, long and cold winter, and also the long night. Okay. And ground surface should be, that means temperature inversion should be taking places. Okay. So here in this fog part also it is similar to the dew only, but somewhat different. In the dew we have the water droplets, but in fog what will happen, that fog means only dust particles will be there. Okay. So that will be what that will be blocking our visions. So that during the winter season when you see in the morning, so that particular you know the fog. And when like in the northern India, due to the crops burning in all other parts, so what we have the smoke plus fog, we have the smoke. So that is the formation of smoke. So there what happening, like means you won't be able to see any part. Okay. So that particular you know the smoke. Even it, and in that case what will happening, you won't be able to even the breathe. Okay. So that is known as smoke. So in that part what will happen, that will be blocking. See, fog and smoke both are same only. Only thing is that smoke also getting added to it. So because that it is becoming a smog, and in this part a smog means we will be not able to breathe the air also. But in fog we will be able to breathe the air, but in smog cases we won't be able to breathe the air also. We will be getting mixed air. So in the sea, this happens, this fog happens in the like continental part, in the downer part, in the valley part. And that same thing, that fog, if it happens in the parts of mountainous area, so that particular is known as the mist. Okay, so that is known as the mist. So here we have the mist formation. Okay, so in the mist formation, difference is what? During the mist formation, difference is what? Here in fog we won't be able to see. So here vision will be blocked. But in the mist part, what will happen? Up to like 1 to 2 kilometers, we'll be able to see in the mountainous area. So that is the mist. Okay. So in this part, what you can see the dust particles present near to our ground surface. That also you can see. But here in the mountainous area, our vision will be somewhat. It will be like 1 to 2 kilometers. So that particular is known as the mist. So see. So in the mist part, what will happen? See, in the fog, we won't have that much moisture. Okay. But whereas in the mist part, we have the moisture content more. We have moisture content higher than the fog part. Okay. So mist contains moisture. So because of that only, there what is happening? There is our vision up to 1 kilometer. So up to 1 to 2 kilometers, we can see the Earth's surface. So that is the mist. Okay. So that is about the mist. Then now about the haze. So haze means what is happening? When all those dust particles from the upper part, okay, that is coming like all those dust are coming down, and that you can see. So that condensed dust particles when it's coming down, okay, dust particles coming down, not without the moisture part. So that particle is known as the haze. So see this here, here you can see that glows at 0 degree as you go up. So that particular will, now what will happen? That vapor will turn into, that water vapor will turn into directly into the solid. That is the ice part. Okay. Then hailstorm. So hailstorm is what? When those, it has changed to ice. Okay. So that snowfall, when we have that snowfall, now in that part what will happen? That solid particles, its size will be up to 5 to 50 mm. Okay, so there will be the bigger size. Okay, and they will be in the solid state. So when they will fall down as a precipitation on our Earth's surface, so they will be falling down on a like smaller parts of ice crystals. Okay, so that particular is known as the hailstorm. So hailstorm formation, how it is happening? So see here. Now we have the, here we have the solar radiation, then we have the terrestrial radiation. So here now hygroscopic nuclei are there. Then here what is happening? Formation of, even in the upper part, that above the 0 degree we have the hygroscopic nuclei. So there what is happening? There that all those water vapor that is turning into the ice. Then what is happening? From here downwards, due to heat loss, we have the warm air going up. Okay. So what is, when only the sum of the ice crystal will come down, again this warm air what will happen? They'll mix and they take them again upwards. Okay. So again by taking that updraft, when that will be taking updraft, so what will be? There will be settlements of some more ice crystal. So because of that, after it, when they will not able to sustain themselves, so due to gravity, they will start coming down. Okay. So that rainfall means what? Not rainfall, you can say it as a snowfall. Okay. You can say it as snowfall. When precipitations happens, that all those ice crystals are falling down like a snowfall. So that particular process is known as the hailstorm. And see here about the sleet. So sleet means what? When those hailstorm is happening, okay, that ice crystals falling. So when those happening, and then when they are reaching the Earth's surface, they are turning into the like a seed type. Like a seed type they are turning. They are falling down as a seed type. So that particular is known as the sleet. That snow crystals only, that ice crystals only, but they are falling down as a seed type. So that is known as the sleet. Sorry. So see, sleet means what? When from the upper parts, what is happening? Slit means what? From the upper part they are falling down as a vertical sheet. Okay, vertical. So that is known as a slit. Vertical is what? Little ice also will be there. So as a vertical sheet they are falling down, as we see. So they are falling down as vertical. So that is in the slit. Okay. Then again, as they fall down and they fall down on the ground as a horizontal. So that slit or as in a horizontal part, that is known as the glaze. So this is about the glaze, slit, and all other types of precipitations. We study about the fog, dew, mist, hailstorm. So all these are types of precipitations. Okay. Now see how we are having the acid rain. How we are having the acid rain. See here, what is happening? You know that now industries, vehicles, all they are releasing smokes and everything. Okay. So what is happening? This sulfur dioxide, nitrous oxide, all these are going upwards and they are mixing with the water droplets. Okay. When they are mixing with the water droplets, so what will happen? You all would have studied about the chemical reaction. So H2O plus SO2. So this acid formation is happening, sulfuric acid formation is happening. So when those droplets mix with the smoke and they are falling down in the form of sulfuric acid, so that particular is known as the acid rainfall. So in acid rainfall, you all know that there will be mixture of sulfur dioxide and nitrous oxide. So this is the part of acid rain. So this was all about the different types of precipitation. So now you must know the all those definitions. So when you go home, see, slit means now on the basis of concept you all saw. So when you briefly just see about all those definitions of slit, hailstorm, glaze, all those parts. So see all those definitions. So this was the part of all those other parts like precipitations and different types. Now we'll see about the rainfall and its different types. So after studying about the rainfall, we'll see about the air masses. So okay, can anyone confirm me where you are able to see the slides of types of rainfall and air masses? Where it is visible to all? New slides?
Yes, sir, visible, sir.
Okay. Okay. So now we finished about the different types of precipitation. So when you go, just go to Google and search for all those definitions. Okay. So it is that only thing is that you can attempt all those questions if questions come from the precipitation. So you must know the definitions. But see, we saw the concept. So without seeing the definitions, also you can easily from yourself you can define themselves. Define all those precipitation. But okay, for your clear understanding purpose, just go for the definitions see on the Google. Okay. So now we'll study about the types of rainfall and the air masses. So first we'll see about the types of rainfall and how this rainfall occurrence is happening. So we see rainfall about the rainfall occurrence. We were saying in the previous most of the classes about the occurrence of rainfall. So again here we'll see rainfall how it is happening. This is our earth part. In the earth part we have the water bodies. So when sunlight, when incoming solar radiation is there, so what is happening? It is heating up the water. So due to increasing temperature, what is happening? These waters are becoming into water vapor. Okay. So they are becoming to the water vapor. So as they are going up, so they are changing to gases. So they are going up as a gaseous part. So when they are going up, what is happening? Temperature is decreasing. So there what is happening as temperature is decreasing and it is going up. So after that near to the tropopause area, it won't be able to travel. They have the only capacity to go upwards in only up to that part. So they will deflect. So in this part and this part. So there what will happen? Dust particles are there. So due to the cooling, they will settle on all those hygroscopic nuclei. So when attraction will happen, then they will start increasing their sizes due to regular water vapor from the incoming solar terrestrial radiation. So after that, what will happen? They will turn into bigger size, and then when they are not able to suspend themselves, so due to gravitational pull, they will start doing the precipitations. So that particular precipitations are known as the rainfall. So condensation of water vapor followed by release of moisture is known as the precipitations. The process of continuous condensation in air helps the condensed particles to grow in size. So that when the size is growing, that all those condensed particles, when their size is growing, so they will turn into the bigger size, and after that they will start falling down in as a rainfall. So we have the different types of rainfall. One is orographic, then we have the convectional rainfall, then we have the frontal or cyclonic rainfall. So this frontal and cyclonic rainfall we'll see in the cyclone part. Okay, cyclone part we'll see all those rains are happening, rainfall are happening when cyclone happens. So there we'll see how fronts is created, then how cyclone is happening. So there we'll see in the cyclone part about the frontal rainfall. Now in this orographic and convection rainfall. So in this orographic rainfall means what? See, while studying the geomorphic process, okay, you all would have studied about the orographic, orogenic and the epirogenic. So there we saw that oro means what? Mountain. Okay. So yeah, orographic rainfall means what? Orographic rainfall means mountainous rainfall. Mountainous rainfall. So that particular is known as the orographic rainfall. And convection rainfall means what? Like due to the heating, we have the water vapor going upwards, like a convectional. Okay. So in the convection it will go up. So that particular is the convectional rainfall. So we'll see all those how their formation happening. All those everything I have mentioned in the slide. So see here. First we'll see for occurrence of rainfall, what should happen? There should be conditions. Okay. There should be a presence of warm air. Then we should have the moist. Warm air should be the moist, and there should be the presence of unstable air. Okay. And there should be sufficient number of hygroscopic nuclei. That hygroscopic nuclei, what? That is dust particles, small dust particles, ashes, then salt, aerosols. Okay. So all these are hygroscopic nuclei that they are suspended in the upper troposphere, in the atmosphere part. Okay. So here we saw that how that rainfall is happening and everything. So only thing that's here. We saw in previous class also that when we have the vertical mixing, so because of that vertical mixing, we have the unstable air. So see here, you all know that what it is happening. From here, what is happening? Warm air is going upwards. Okay. It is ascending. Then from the upper part, what is happening? Cool air is coming down. Okay. So here what will happen? Warm will go upwards and cool air will come down. So in this particular case, what will happen? Cool air will settle down here and warm air will be going upwards only. So in this case, what will happen? You all know that cool air descends and warm air always ascends. So in this case, what happens? There will be no mixing. So no mixing of these both air. So then that takes the place of stable condition. Okay. And in this case, what will happen? Now when it is containing all those moisture part. Okay. So with the moisture part, it is going, and here we are finding the hygroscopic nuclei part. Okay. So because of this presence of hygroscopic nuclei part, what is happening? There is a mixing of all those from here, moisture also going and settling down. From there, cool air also coming. They are also mixing with all those dust particles. So here, what is happening? Mixing is happening. Vertical mixing is happening. So this particle is known as the unstable condition. So that is the unstable air. Okay. So in that only that mixing happens. Then that all those small parts they condense themselves. Then after it when become bigger in size, then they come down to the earth surface as a rainfall. So these two conditions you must remember, and one more condition you must remember about the relative humidity. that it should have 100% relative humidity. Okay, and means what? If it has the 100% relative humidity, what? That has been saturated. So means what? It should have the saturation of all those air. So that particular is known as the rainfall when it comes down to the earth surface. So this is about the rainfall. Now in the convectional rainfall, how it is happening? See, convection rainfall. This is our earth surface. Okay. Now here is our sunlight. So from here that directly sunlight is coming to the Tropic of Cancer, this part and equator area. So here we have the ascending of air. So as these are going up, so what is happening? There are formation of condensed part here. Then again warm air is going up. So this what is happening? This when this dust particle trying to come down, again this warm air push it the upwards. So like a convection we saw in the while studying about the interior of the earth. So what is happening? Due to convection current, it is pushing this first part upwards. So there is a breakage fault in this area. So in the similar in this type also it will push again upwards. So again those dust particles will go upwards and it will settle down. So again it will settle down. So again after it what will happen? When their sizes increases and when they are not able to hold themselves, then they will fall down. So here whatever in the Tropic of Cancer and Tropic of Capricorn area and in the equator area. So mostly in the equator area, rainfall is happening due to the warm air, due to the convection. So due to the convection here what is happening? Rainfall is happening. So this particular is known as the convection rainfall. So that is this is what due to the heating of our earth surface. So due to the insulation of this part that is happening, so that is known as the warm air. Okay. So in this warm air is going. We had a study that as it goes up, so what will happen? It will be cooling down. But there what will happening in the upper part? What it will be happening? See, all those moistures they'll be like a heat part. Okay. When they go up and they will settle on those hygroscopic lines, then after what will happen? There is the lose of this heat loss will be there. There will be heat loss in this part. So again there will be the release of warm air. So again that will push the hygroscopic nuclei in the upper part, so condensed part. So light clouds will be forming. So they will be spreading. They will be spreading to a longer distance, and clouds will be formed. So that particular what will happen? Then after when they have reached their maximum capacity and they start falling down. So that particular rainfall is known as the convectional rainfall. And mountainous rainfall is what? Orographic rainfall is what? When the rainfall happens due to the mountainous process. So that is known as the orographic rainfall. So see, the air on being heated becomes light and rises in the convection current. So as it rises, it expands and loses heat. Consequently, condensation takes place and cumulus clouds are formed. So when convection is rapid and intense, the cumulonimbus clouds are formed. So due to this part only, cumulonimbus clouds are formed. So due to the thermal heating only, cumulonimbus clouds are formed. Okay, and these cumulonimbus clouds we'll see in the cyclone. That how it forming is happening. And during the cyclone, we have maximum all those cumulonimbus clouds rainfall only. So now about the orographic rainfall. So see here, this is our mountain. Okay. So here what is happening? From here this warm air is coming. Okay. From here what is happening? This is our mountain side and this is our leeward side. So in this part what is happening? So see, from this you can better understand from the diagram. So see, in this part what is happening? We have the high pressure in the downwards, in the valley area. Why? Because in the high valley area we have somewhat low temperature, and we all know that wind blows from high pressure to low pressure. So here what will be happening? When this high pressure is going upwards, so all those hygroscopic nuclei parts settle in this part. They will start settling in this part, and here we have the rainfall in the windward side. In which side wind is blowing, so there we have the rainfall. So that particular is known as the orographic rainfall. So in the orographic rainfall we have rainfall in the windward side. Okay, and in this leeward side, so see where we have the wind blowing. Okay, so that is the windward side, and this behind area that is known as the leeward side. So in this parts, what will happen? There will be no clouds. So here we have the dry wind. So dry wind means what? We won't have rainfall. Or if we have the rainfall, then we have the very little rainfall. So this particular is the orographic rainfall. So it occurs when air is ascending due to the mountain barrier. So this mountain barrier, that in India also you can see. Suppose if this is our part of India, so there, here also you can see, here is the Western Ghats, and when the trade winds, okay, when they are blowing from this part, and due to the mountain barrier in the Western Ghats, what happened? It is going and hitting that part. So there, all those clouds settling. So because of that, what is happening? In the windward side, we have the rainfall. So that is known as the orographic rainfall. So now in this applications, what you should remember that how we are having rainfall in this part in the monsoon area in the Western Ghats, that is due to the windward side of mountains. So that is the orographic rainfall. Okay. So this is about the orography, and why we don't have, see, trade winds going in this part also, but here in this part what is happening? We are not having the rainfall in this area. Why? That because there is no barrier. So because of that, we won't see any rainfall this part. And if you will be getting like confusion, then why sir Bangladesh is fully like flooded? Why? See, Bangladesh is fully flooded because from this side, from the Uttarakhand side, we have the Ganga river coming. Okay, from here this side it is being water and segments. From this side, all those rivers, devastating rivers, Brahmaputra, Tista, that is flowing in Sikkim. So that they are flowing. So you know that these are the longest river, and they have the high volume of water. So that because of that rivers only, Bangladesh is a flooded area. Okay. So don't get confusion that because of rainfall, because of monsoons, Bangladesh is flooded. So be clear with it. So see, everything are given. See, even in the Patagonian Plateau Desert in Argentina, so the area situated on the leeward side. So the area situated in the leeward side will see all those desert area. So due to orographic parts only, we have the one area desert and other area is all those rainfall feed area. Okay. So now see, similarly in the Indian side also you can see we have the presence of Thar desert. We have the Thar desert in this part. Why we have the Thar desert? See, here we have the Aravalli mountains. Okay. So when wind is blowing, when it is going towards this side also, so it is hitting here. So here we have the rainfall this side. Okay. But where this part is the leeward side. Okay. So leeward side there will be no rainfall. So we have the desert area in this part. So mostly you will be seeing all those desert area in the leeward side of mountains. So see here, and that particular leeward side is known as the rain shadow area. Okay. So see here, the area situated on the leeward side which gets less rainfall is known as the rain shadow area. So some arid and semi-arid regions are a direct consequence of the rain shadow effect. So that examples you can see in the Patagonian desert, that is in Argentina. Similarly, you can see the Thar desert in this part. Similarly, you can see even the Sahara desert also. So all these are parts of rain shadow area. So they are in the part of leeward side. So this was all about the orographic rainfall. Now we will see about monsoonal rainfall is a part of, like you can say it as a part of orographic rainfall. Okay. Now we will see about the frontal rainfall. So frontal rainfall, how creation will happen? See, downwards pass when we have the cold air. Okay. And see how front is created. First we see now warm air is coming from this side. Okay, horizontal, and we have the cold air from this side. So here what is happening? You all know that cold air descends, warm air ascends. So in this part, what you see, when the two air masses, when they converge, okay, when they meet, so what will happen? This warm air will start rising. Similarly, you have seen the plate, that oceanic crust plate and the continental crust plates, like density part. So here similarly in this part also, cold air will start descending. So in this part what will happen? here there will be turbulence. Okay, so in the similar way, what warm will keep on going up and this part will be coming down. So in this particular formation, you know the front. So when we have the rainfall due to the front formation, so that particular rainfall is known as the frontal rainfall. So when two air masses with different temperatures meet, turbulent conditions are produced. So along the front, convection occurs and causes precipitation. So that what in the northwest Europe, we can see that cold continental air and the warm oceanic air converge to produce heavy rainfall. So mostly frontal rainfall we have the near the water bodies. Okay, because in water bodies only we have the formation of front. So most of the front formation will be taking places in the near to the water bodies. Okay, or you can say that water body and nearby its land area. So their front formation will be happening. So this is all about the different types of rainfall. And frontal rainfall will be able to easily understand all those parts easily in the cyclonic, when you study about cyclone and also about the fronts. So there you will be able to understand all those parts. Okay. So now we have finished about this part, about the frontal rainfall. Okay. So now we finish about the different types of rainfall. Now we go with the air mass convergence. So now we will start with the air mass. So see, by studying the air mass only, we will be able to understand the part of front part. Okay, that how that cold front formation is taking places, then how cold front is taking places, how warm front is happening, how a stationary front is happening, how occultated fronts are taking places. So that all those fronts will be able to understand by while if you understand the part of air masses. So what is air mass? So air mass is what? Large body of air. So okay, so large body blowing. So that large body masses of air is known as the large body of air is known as the air masses. See, large body means what? That particular that airs, they will be blowing like more than 100 to 1000 kilometers. Okay, so when that particular, suppose warm wave is coming from this side. Okay, so means warm wave coming from this side means what? It is coming from behind like 100 kilometers. Okay, so it might go up to the like 1000 kilometers also. Okay, so that large body of air. Okay, so that is the air masses, and how that large body creations happens and how the air mass formation is happening. There are two conditions. One condition is that in the atmosphere, we should have the uniform temperature. Okay, when we have the uniform temperature and also uniform moisture content, so that particular, even the warm air with the uniform moisture and it has the uniform temperature, so that will be forming the warm air mass. And if it has the uniform temperature, uniform moisture, that cool air, so that will form the cold air. So we have the two different types of air mass. One is cold air mass and another one is the warm air mass. So it should fulfill these two conditions. It should have the uniform temperature. Suppose if it is cooler part, means if it is 4 degrees Celsius, means it should have that. If the wind is blowing like from 100 kilometers to 1000 kilometers, if it is blowing, so what should happen if the wind is cool only? So then also that all while it is blowing from this part, at whole part it should maintain the same temperature. Suppose if you take it the 4 degrees Celsius, then it should have the 4 degrees Celsius in all other parts also. Then only that cold air mass formation will take place. Okay. Then similarly in the warm air mass also. So that uniform temperature is with that, and then moisture also should be uniform. So that is the air mass, and two types of air mass are the cold air mass and warm air mass. Okay, so in cold air mass, how it is happening? Temperature of air mass that is lower than the line surface. So when we have the temperature, that cool air when it is blowing, and we have that cool air temperature lower than the line surface. Okay, so that is known as the cold air mass. So all this type of cold air mass you can see in the temperate regions only, temperate or polar regions. So like when you go near to the 60 degree, there you get the temperature. So in these parts, here what will happen? Here we have the low pressure area. Okay, so as low pressure area is what here, somewhat heat will be there. Okay, and from here what is happening? High pressure is coming. So from here what is happening? We have the temperature less. Here we have the temperature less. So in that particular landform, cold air mass formation will be happening. So see, all those cold air mass and this part what is happening, see in this part only at the 60-65 degree part only, there will be the front formation also. When we are studying for the front, there will be easily able to understand the part of front. See, and the warm air mass is what? That warm air mass is designated as the air mass whose temperature is higher than the low lying surface. So that low lying surface is what you can see in the that tropical subtropical part. So there we can see that warm air mass. So that is the warm air mass. Means what? That low lying surface should be somewhat cool, and that air mass blowing upwards, that is the upper part. So that should have the temperature high. So that is the warm air mass. Then see, so source in this out, and then temperature, moisture, that should be the uniform. Okay, so this is about the cold air mass and warm air mass. So and there should be homogeneous. So homogeneous, that we studied that. See, if we go in the ocean area also, so there must be homogeneous land or oceanic area. So that homogeneous oceanic area should be there. Okay, then there should be no convergence of air. If convergence of air is there, then what will happen? There will be the frontal formation. Then after it, there might be the like hygroscopic nuclei will be condensing. Then there we will have the rainfall. So in that case, there will be no air masses. Okay. Then atmospheric condition, they must be stable. So these are the conditions for the air masses. These are the source region. If that from that particular region, say if from that particular region, if air mass is there, then in that particular region, that air mass should be in all these three conditions. It should be fulfilling. Okay, that particular source region, that land part, it should be fulfilling all those three conditions. Then only you will have the air masses in that particular parts. So cold air mass means that we saw that like above 60 degree we will see the cold air mass. So there means what? Polar region and also Arctic region will be seen. Temperature should be low. Its property is that temperature should be low. Specific humidity, that should be the extremely low. Then it should have the stable air, and it should have the rate of temperature, or the lapse rate should be the low. So lapse rate low means what? As you go up, that temperature will begin. So that also should be the less. So what will happen? In that case, what happens? Cold air mass formation takes place, and the warm air mass. So cold air mass, when they are reaching to the other areas, so temperature of that area, it brings that temperature of that area also that decreases. Okay, so in that case only, see cumulonimbus, that cloud formation happens. So in that case only cumulonimbus cloud formation happens. So in that case, what will happen? Now that particular at that place, what will happen? That hygroscopic nuclei, they will become in the cold, so they will be condensed. But again, what will happen? Now since warm is there in this part, so what will happen? Heat loss will be happening in this part. So because of heat loss, again these particles will start going up. So in the upper part, they will start forming branches. So they will take the shape of cauliflower. So cold air mass is moving over warm ocean current. Then its specific humidity, that should start increasing. Okay. So a specific humidity, so relative humidity we studied. So a specific humidity means what? At that part, it should maintain that particular humidity. It should have only that particular moisture. It should not have more than. So that is known as a specific. For something that one humidity is mentioned, so that is a specific humidity. So see here. When cold air mass is moving over the warm continent, then means what? You should have the clear weather and clear sky. Then only we have the cold air mass. So remember, there should be the what? Formation of temperature inversion also. Okay. Then we have the two types of cold air mass: continental cold air mass, nighttime cold air mass. So continental cold air mass means what? On the Earth's surface. The nighttime is the oceanic part. So in oceanic part, how that cold air mass is happening? See, when it is hitting the ocean part, so here what will happen? That it will change to the vapor and it will be going up. So here upper part, what will happen? Warm air will be going up. Then this particular water will be pulled down. So this, here you have the cool air downwards and warm air going up. So here what will happen? There is a formation of frontal type air mass. So here we have the cold air mass. Then continental cold air mass. So in that also same formation happens. So when we have the cooler surface, that line surface is cool, and in the upper surface what it is? Somewhat warm. So that is the cold air mass. Okay, then warm air mass means that originates in the subtropical regions. So when the temperature of air mass is greater than the low lying surface. So when the temperature of air mass is greater than the low lying surface, then that is the warm air mass. And in cold air mass, what happens? That you can see in the Arctic region, all those polar areas. So what will happen? Those areas, all the temperature will less only. Okay. So in these parts, what happens? When from the temperate region part. So here we have a little bit warm air, and here we have the cold air. So there, the temperate region formation of cold air mass will be happening. Okay. Then warm air mass means it happens mostly in the subtropical regions. So now there are different types of air mass. Okay. So that particular air mass are maritime polar. So see here. Now in this, to remember all this, you must remember all these parts. So see here. P means, you all know that, polar. Then T means tropical. Don't say temperate. T means tropical. Okay. Then C means what? Sorry. A means Arctic and C means continental. Okay. Then and T means tropical. So T means polar. So now in this case, see, by studying these parts, so in this also you can easily guess that what type of air mass will be present in those parts. So see here. M means what? Maritime. So remember this short. So see here. Now here one type of air mass is MP. So M means what? Maritime. Okay. And P means what? Polar. So polar, what we have? We have the moisture this side. Means what? Cool air is there. Maritime is what? Maritime. So maritime, polar. So maritime is what? There that ocean is there. So there what? Since that is maritime area, so there what will happen? We'll have the water area part. So this maritime is little bit moist. So it brings the moisture in this part. Okay. And polar is what? Little bit cool. Okay. So in this maritime, polar air mass is the little bit cold and moist. Okay. Then maritime tropical. M is maritime and T is tropical. So maritime tropical is what? Maritime is what? You know that moist will be there, and tropical means warm. So tropical means what? Sun is falling overhead on these parts, so temperature will be warm there. So there warm moist will be there. Okay. So that that atmosphere, we will have those atmosphere warm moist, and maritime polar will have the polar moist, cold moist. Okay. Then in continental Arctic. Okay. So continental Arctic is what? In those parts it will be cold only, and it will be dry. Okay. So it will means what is that? All those particles, water droplets, everything will ice part, so it will be dry. So that is here what will happen? We have the cold dry. Then continental tropical. So here in continental tropical is what? We have warm dry. So you all know that tropicals will have the warm and dry also. That means what? There will be like temperature is falling down. So we have the warm also, and continental part you all know that it will be warm also, warm dry in the tropical part. So by the name, you can easily guess that what type of air mass would be present. And continental polar is what? Or polar area, as that crust area where settlements are there. So that will be what type? So that will be a cold type only. So this is all about the different types of air masses. So in these different types of air masses, first we'll see the definition. So see here, in this, an air mass is a large body of air having little horizontal variation in the temperature and moisture. Okay, so they extend from surface to lower stratosphere or across thousands of kilometers. Means what? They are in the parts of lower atmosphere, and after that they might go thousands of kilometers also. So conditions means what? Conditions, what are the conditions? So a source region should be extensive with the gentle divergent air circulation should be there. So what? Anti-cyclonic circulation should be there. Then based on the source region, we saw that warm tropical and subtropical oceans, subtropical hot deserts, all these are the relatively cold high latitude oceans, the very cold snow covered parts, continents in high altitude, then permanently ice covered continents. So all those naming we saw. So these naming are based on these parts only. That maritime polar, continental polar. So see, maritime tropical, continental tropical, maritime polar, continental polar, continental arctic. So by the full form, you can easily recall that what it really is the full name. Okay. So they are the different types of air masses. So in this, so what is happening? The first letter in this air masses, first letter describes moisture properties. Okay. So now this you must remember. Suppose if Ca is there. So Ca means what? This is continental. This is arctic. So here what is happening? This continental means what? It describes the moisture content. Okay. So it describes the moisture content. So moisture means if continental, if we have means what? We have the dry. And if we have the maritime means what? It will be moist. Okay. So in that way, you can say, you can define all those parts. So here we have studied. Now see, first letter describe the property of moisture content, and the second letter describe the source region of the air masses. So now in this part, see here. When we saw the different types of masses, so in this part, see by the name you can see first name what it is describing. It is describing the moisture content. Okay. So moisture content it is described, and second part is the source region. Source region. So here you can see maritime polar. So maritime polar means what? This is moist. Okay. And polar means what? It will be like cool. So moist and cool will be there. Okay. Then here we have warm and moist. Maritime tropical. So tropical, you know that it will be warm. So and maritime is moist. So in that, so first letter denotes the moisture content, and second letter denotes the continental region, that source region. So this is about the different types of air masses, although different types. Okay. Now cold source region, that polar air masses, cold source region, how it can be? Like in Arctic regions, you can see. Then Siberia, there we have the cold and dry. Then northern Canada, we have there again we have the cold and dry. Then we have the southern ocean in southern side, that Antarctica side. So there we have all those cold air masses. Then warm air mass means what? It is which is warmer than the underlying surface. That air mass that is blowing upwards, so that is warmer than the underlying surface. So that you can see mostly in the desert parts. Okay, the Sahara deserts we have, then ocean parts also we have all those parts. So there we can see the tropical air masses. Then continental air masses are dry, cold, and stable conditions will be there. So see, just you remember those full forms. That will be helpful for you to recall, to have a clear understanding of all those parts. So in that way, that names you must remember that about the all those parts. Means what? How if it is Ca, so it is continental Arctic. So it is in the Arctic region. So by these parts also you can know their angle, at which angle they are located. Okay. So see, maritime polar air mass. Okay. So polar means what? It will be in the polar area. Okay. And since in the full polar, that is at 90 degree, what we have? We have like there mostly we have the snows, glaciers we have, all those ice crystals. Okay, so there is what maritime is there. So maritime is, you can easily understand that we have the moist. But where we have the glacier is what will happen? There will be dry conditions. So maritime polar is what? It will be near to the 40° and 60° latitude. So that subpolar regions we have seen, that 60° south, 60° north, and 65. So there we have seen. So that is the maritime polar. So by these parts also you can guess all those angles. Okay, and now from this part you all can understand about the, if you see on the world map also, all those different types of air masses. By these parts also, by understanding the different types of air masses and understanding those conditions, that how that, what does the first letter denotes, what does the second letter denotes. So by this way you can easily understand on the world map on which type of region, which type of air masses will be present. Okay, so maritime polar mass, they are located between 40° and 60° latitude. So here what happened? Regions are cool, moist, and unstable. So continental tropical air mass means what? Air masses include the tropical and subtropical deserts. So here what happens? We have the air masses that are dry, stable, and do not extend beyond the source. Then you get the maritime tropical air mass. So by by understanding those denotation, so denotation of all those naming. So by this you can easily guess the all those degrees at which place it is locating, and you can also guess the moisture content, whether it is warm or whether it is cool. So by knowing the name itself you can guess. Okay, so now see, so this classification of air masses, all those air masses we saw. So maritime air mass means what? It will be forming over the water. Continental air mass is what? It will be forming over the land. Then we have the polar air mass. So that is the polar area. Then tropical area means what? That will be the tropical area. Now this is all about the fronts. So they are the typical feature of mid-latitudinal weather. So that fronts part we will study in the next part. So see, now fronts is what? Their typical features. We saw that warm air will be ascending and cold air will be descending. Okay. So when after ascending, what happens? When those it becomes the shape like this, or you can also say that now warm air is blowing and this cold air is descending. So in this wave formation, fronts formation takes place. Okay, fronts formation takes place. So fronts are typical features of mid-latitude weather. So they mostly all these fronts happens where, see, now on the Earth's surface you all studied this is equator, is here we have the low pressure. Then here we have the high pressure. Okay. Then again here we have the low pressure, and again here we have the high pressure. Okay. So here what is happening? See, from this part we have the warm wind blowing this side. Okay, warm wind. From this side what is happening? Cold wind blowing from this side. Okay, so we have mostly all those fronts formation in this part. So their region you can say it has the 30° to 65° north and south. So mostly they will be located within the temperate regions. Okay, so remember that one. So here what is, when here now see warm air and cold air, they will be converging. So in that case what will happen? Warm air will descend, warm air will ascend, and cold air will descend. So in that particular what will happen? There will be a formation of fronts. So mostly that will be located between the 30° to 65° in the both northern hemisphere and the southern hemisphere. Okay, so front is a three-dimensional boundary zone formed between two converging air masses with different physical properties. So temperature, humidity, densities. So they are the different. So here from here now due to high pressure, from here warm air is blowing. So here temperature will be high. Then humidity. So here means what? They have the moisture content. Then its density will be what? Warm air is going this side means what? Its density will be somewhat less. Then cold air coming from this side means what? Warm air is going means what? Density will be somewhat high. And from here cold air is coming means what? Density will be somewhat less. So it should have the different physical property. All the physical properties should be defining those, all those where it is cold or it is warm. So here you all can see in the this part also. So warm front we have, cold front we have. So all those stationary front, then occluded front. So now all those front types we'll study in our, now if we have the time in this part, or we will study in the next class. Then after studying about the fronts, we'll see about the, first we'll see about the Copen's classification. Then next we'll see about the other parts, that is cyclones. Okay. Then we'll see about the polar vortex. So this is all about the, those front parts, sorry, air masses part. So now see, I have opened the slides of, yeah. Sorry, this is a Copen's classification. Okay, that front part we'll see tomorrow in the class. So before front part, we'll see about the Copen's classification. So don't go into diagram. I say here, this is the front part. So in the Copen's classification, you must remember, see, this is the most part, what will happen. See, in exams about the Copen's climatic classification, so some questions are being asked in this part. So there you must understand. So see, in this part, what is happening. Sorry, this is the part of front only thing that name is changed. Okay, this is the part of front only. So in this, see, now you all know that tropical region is what? That will be mostly tropical means what? Here 5 degree to here this area. So that is a tropical region. Then we have the subtropical area. Then we have the polar front area. Then we have the temperate area. Then we have the polar area. So that all those we'll see in the tomorrow classes, and we'll see about the different types of fronts also. Okay, still now we are on the same slide. Okay, our slides and everything. Okay, so with this, we'll finish up the class. So this was all about the front part, air masses, and different types of rainfall, and also the precipitations. So front part, still we have not studied, only we have seen the definitions. So front part we'll see tomorrow. So see, tomorrow we'll see about the front part, then we'll see about the Copen's classification, then also we'll see about the all those cyclones, and mostly we'll try to finish the climatology part tomorrow itself. So tomorrow you all come on the time, and ask your friends also to come on the time. So there we'll be able to easily finish up our syllabus of oceanography, climatology. Then we'll start the oceanography, and within 2 to 3 days we finish the oceanography part, and after that we'll study about the Indian geography part. So for the studying about the Indian geography part, we'll have the extra classes. Okay, because now we have the less time, so now quality class will be also starting. So there in the same time quality class you all will have, and we'll study about the Indian geography in the extra classes. So I'll announce all those schedules. So there we'll study about the Indian geography. So that's all about these parts. So any doubt in these parts, you all can ask for me, and ask your friends to come on time tomorrow, because tomorrow if you come as early as possible, if you come by the 5:31 itself, so there we'll start our class fast in the first process. Then after we'll try to finish up the whole climatology part. So that day after tomorrow we'll move to the oceanography part. Okay, so that's all for today, and go through all those slides, and if any doubt you can ask in the later part also, you can ask in the WhatsApp message also. So go through all those slides and have a revision. So that's all for today. Thank you all. Jai Hind. We'll meet again tomorrow back at the same time. Thank you.